Okay, so 1998 test, we're going to start with number 3. So it says the slope of the tangent line. So I'm going to have to do implicit differentiation here. Okay, so on number 3, when I take the derivative of y squared, it's going to be 2y. But you have to do chain rule. So because if you're just taking the derivative of x, dx over dx is just 1. But we're taking the derivative of y with respect to x. So I have to sprout a dy over dx. Plus, I'm going to do chain rule for this part. So I bring the 3 to the front, keep the inside the same. Subtract 1 from the exponent. And then multiply by the inside function, which is xy plus 1. So when you take the derivative of xy plus 1, I have to do product rule for xy. So it's the first factor times the derivative of the second, plus the second factor times the derivative of the derivative of x is just 1. And then when you take the derivative of the constant, 1 is just 0. And then you take the derivative of the right side of the equation, so 0 is a constant, so the derivative is 0. So now I just have to solve for dy over dx, and that's my answer. So to solve for dy over dx, actually first I'm going to plug in these numbers here. Makes it a little easier. So everywhere I see a y, I'm going to put a -1. Everywhere I see an x, I'm going to change it to a 2. So x is 2, dy over dx minus 1 equals 0. Okay, so this becomes -2 dy over dx plus this whole thing. When you simplify this, it's going to be -2 plus 1 is -1. When you square that, you get 1 times 3, you get 3. And then I have 2 dy over dx minus 1. So this becomes -2 dy over dx. I distribute the 3. I can combine like terms here. So that just becomes 4 dy over dx. I can add 3 to both sides. So when I solve for dy over dx, just divide both sides by 4. So my answer is 3/4. So it's letter D. That was good practice of implicit differentiation. So hopefully now that we've done 3 tests, you're starting to see a lot of the same types of problems over and over again. Like even if it's not multiple choice, you can still, through doing multiple choice problems, you can see the concepts that you're expected to really know, the ones that College Board likes to focus on. So I'm sure you're going to see a lot of similar type questions, whatever they put on there. I still don't expect there to be a lot of surprises, but I guess we will find out sometime in May. But I don't anticipate them trying to trick you. I don't think they're like that. They just want to make sure you know how to do calculus. Okay, so other questions on 1 through 8.
Can you do number 5?
Number 5. Let's do 5. I'm going to clear this screen unless someone tells me not to. Okay, it's number 5. I like these problems where they give it to you in functions and have you take the derivative, in this case, the second derivative. So right here, I'm going to first take the first derivative. So this requires you to do chain rule when you have a function inside of a function. So g of x is inside of the f function. So whenever you're doing chain rule, you take the derivative of the outside function, keep the inside the same, and you multiply that by the derivative of the inside function. So that's chain rule. Derivative of the outside, keep the inside the same, multiply by the derivative of the inside. So, but it's asking for the second derivative, so now I have to do product rule. So product rule says I'm going to take the first factor, or it looks like how they wrote it here, they did the derivative times the first factor. It doesn't matter which factor you take the derivative of first. So I do f, when I take the derivative, this is my first factor, this is my second. So I'm going to take the derivative of the first factor. When I do that, I have to do chain rule here. So take the derivative of the outside, keeping the inside the same, by the derivative of the inside. So product rule says you're taking the derivative of the first factor, keep the second factor the same. Now I'm going to do the derivative of the second factor, multiply that by the first factor, which is f prime of g of x. Hopefully one of my answers looks like this one. So for number 5, this looks like a, because g prime of x times g prime of x gives me g prime of x squared. And then just switch, no big deal. So f prime of g of x times g double prime of x. So you have to test your ability to do product rule and chain rule when it gives it to you in function notation.
Thank you.
Can you do number 4?
Number 4, yep. So I'm going to clear this out. Number 4, just from looking at the answer choices, I think this is partial fractions. See how they like partial fractions. Okay, so I'm going to start off with a little scratch work. So I'm going to say I'm going to factor my denominator here. So it's x minus 4, x minus 2. It's going to equal some number over the first factor, we'll call it a. And then plus a different number over the second factor, we'll call that different number b. So I'm just rewriting this fraction as the sum of 2 fractions. This will allow me to integrate it. So if you want to solve for a, ask the question, what number makes the denominator under the a equal to 0? You can tell me. I like feedback once in a while, so it's not just me talking. What number will make the it'll make what number?
4.
4. So when I cross off this and I plug in 4, it's going to give me 1 over 4 minus 2, which is 1/2. So I have 1/2 here. And then when I want to solve for b, I cover up the x minus 2 and I plug in 2. So 1 over 2 minus 4 is negative 1/2. So I can rewrite the original integral as the integral of 1/2 over x minus 4 minus 1/2 over 2. And this whole thing is with respect to x. Okay, so I'm going to factor out a 1/2. This is 1 over x minus 4 minus 1 over x minus 2 dx. This is going to equal 1/2 times the ln of absolute value of x minus 4. Parenthesis minus ln of the absolute value of x minus 2. And if I look at the choices, this isn't there, so I have to do quotient rule to make it look like one of the answer choices. So this is going to be ln of the absolute value of x minus 4. Because you're subtracting logs, you divide the numbers, x minus 2. And don't forget, you should put the plus c here and then plus c here. So for 4, that's going to be a. Okay, anything else on 1 through 8?
Can you do 7?
Can you go over number 8?
Number 8, absolutely. So I'm going to clear this off and then do number 8.
Also 7, please.
Okay, just remind me after, I'll probably forget. Okay, so number 8. So it says, what is the value of y when x is 0? Okay, so on number 8, this is a differential equation. So whenever you have a diff-EQ, differential equation, you want to separate the variables. So I want to get all the x's on one side and then all the y's on one side. So for number 8, it's going to look like this. So I have dy, I times both sides by dx. And I need to hear somebody again. Maybe Renell. Renell knows. What do you do after you separate the variables? Make sure your mic is turned on, Renell.
You forgot the dx.
No, I didn't. I just haven't put it yet. Just kidding. You there, Renell? There he is.
You take the integral.
Good. I knew Renell wouldn't let me down. So I take the integral of both sides after I separate the variables. So I would not be surprised at all if you have a differential equation on there on the AP test. So even though it's shortened. So I'm going to take the integral of both sides. So on this side, it's just y. When you take the integral of the right side, I don't want it. Integration by parts doesn't look promising here. So I'm going to do u substitution. So I'm going to let u equal the inside function, which is cosine x. So that's inside of u squared. And then that means my du is going to be negative sine x dx. And sine x shows up in the integrand, so that's a good sign. So I can multiply both sides by -1. So I'm going to rewrite this integral as, instead of cosine squared x, I'm going to write that as u squared, because I'm squaring my u that's defined to the right. And then instead of sine x dx, I'm going to substitute that with negative du. So I'll pull out the negative and put a du here. So y is going to equal negative u cubed over 3. Don't forget your plus c. I'm going to plug u back in. So u is cosine x, so this will be negative cosine cubed x over 3 plus c. And I see my answer choices are all constants. That means I have an initial condition somewhere. So my initial condition, it says y equals 0 and x equals pi over 2. That's to help you solve for c. So I'm
Mr.
going
Mark.
to change y to pi over 2. Yes.
Wait, never mind.
Okay. Sorry, y is 0. I'm glad you stopped me, slowed me down to think. So y is 0 and x is pi over 2. So I'm gonna write it like this. Cosine of pi over 2, that whole thing is gonna get cubed over 3 plus c. So cosine of pi over 2, that would be 0. So this is just negative 0 over anything, it's just 0. So c equals 0. So if c equals 0, I can plug this in here, my c just goes away. What is the value of y when x is 0? Okay, got it. All right, so my equation is going to be y equals negative cosine, I'm going to write it like this, x cubed over 3. But the last sentence of the problem says, what is the value of y when x is 0? So I'm going to say y of 0 equals negative cosine. What's cosine of 0? Someone speak up.
1.
1. So this is going to simplify to negative 1/3. And I could see a problem like this too, because it involves several different concepts we've learned. So that's my guess, is it would be something like this involves a lot of stuff. So I could, again, I'm not part of the group that writes the test, but this would be a problem I could really see being on there, something similar to this one. Because it has you tie several concepts together. Having fun, Daniel?
Can you do number 9 after this?
Yeah, I'll do number 9 when I go to the next page. Anything else on 1 through, I'm sorry.
7, please.
Kyler, you said 7? Okay.
Yep.
So I'll do 7 here. So I'm going to clear this. Okay, so number 7. If you try doing u substitution here, you're going to get in trouble because you can't have du in the denominator. So this is one we've seen probably on the last 2 AP tests. You did one like this where you have to split this up into 2 fractions. So I'm going to write it like this. So it's going to be x squared over x minus 1 over x. And this is going to simplify to x minus 1 over x dx. Or this is going to turn into x squared over 2 minus ln of x from 1 to e. So this is going to equal, when I plug e in, I get e squared over 2 minus ln of absolute value of e is just e, minus, I'm going to put a parenthesis here. When I plug in 1 squared over 2 is 1/2, minus ln of absolute value of 1 is just 1. So this is going to simplify to e squared over 2 minus, you should know that ln of e always equals 1. Ln of 1 is 0, so I just do minus 1/2, which is e squared over 2 minus 3/2. And I don't see the answer choice, but I'm confident it's either D or E. Do I have it here? 7 would be E. Okay, anything else on this page before I do number 9? Okay, so I'm gonna go to number 9 now on the next page. Number 9. Oh, this is a good one. I'm glad you asked number 9. Again, this is another one I could definitely see as a good candidate for something you'll see on your AP test. Okay, so it's the flow of oil in barrels per hour. So if this is in barrels per hour, isn't this the graph of a derivative? Isn't barrels per hour a rate of change? So barrels per hour, that's a rate of change. So it's asking about the total number. Didn't we talk about on Wednesday? If you want to find the total number, you have to, if you want to get from a rate of change to an accumulation, a total amount, you want to take the integral. For some reason, it's not projecting. So I'm going to unshare this and share it again. Hopefully that'll fix whatever the problem is. Okay, so barrels per hour. That's a rate of change. So I want to undo a rate of change. That means I'm going to integrate it. Isn't the application of integral, isn't the integral the area between the curve and the horizontal axis? So all I have to do to figure out the total number of barrels is find the area under the curve. So for this one, I want to find this area here. So how many of these boxes are there? If that's one box.
4.
There's 4, right? Actually, no, there's more than 4.
Oh, there's 5. For
There's
the
5.
for the complete
We
one.
have all of this down here. And that counts as 4 boxes. Isn't this half of a box? Isn't this half of a box? So total, we have 5 boxes. So let's find the area of one box. So if I want to find the area of one box, I'll just focus, it doesn't matter which one, I'll just focus on this one. So if you want to find the area here, this has a base of 6 from 8 to 24. It has a height of 100. So each box has an area of base time, which is 600. And there's 5 boxes, so I would do 5 times 600, and that's my answer. So 5 times 600, there's approximately 3,000 total barrels of oil. So that forces you to understand that the integral, when you integrate a rate of change, that gives you an accumulation, how much of something. In this case, it's the total number of barrels of oil. Yeah, at the very end of Monday's session, we said, I gave you the velocity example. So if you want to figure out how many miles you travel, you take the integral of velocity, which is the area under the graph. Okay, what else on this page?
Number 11.
Number 11. Let's look at number 11. Okay, number 11. It says a linear function. Isn't a linear function y equals mx plus b?
Yes.
So right here, I'm going to think of this. Think of f of x. Instead of y, I'm going to write it as f of x. So f of x equals mx plus b. If you take the derivative of both sides, f prime of x equals the coefficient of x, which is just m. The derivative of the constant b is just 0. When I find the second derivative, what's the derivative of m, which is a number?
0.
0. So that means I'm taking the integral from a to b of 0. What's the integral of 0? Anyone?
0.
Would it
It's
be
just
0?
0. It doesn't matter because there's no rectangles if it's just 0. So the integral of 0 is just 0, so the answer is A.
Can you do 12?
Yep. So I'm going to do 12 next. Everyone is okay with number 11?
Can you hold on for a sec?
I can. And while I'm waiting, just everyone heard me, so we will have a, we're not done yet, but so everyone knows we will have a session this Friday, but next week we're only meeting Monday, Wednesday, because I'm going to be having you do Albert IO stuff towards the end of next week. So that's all on there. You can start that anytime. So just kind of, you can stick around after if you have any questions. Hopefully everyone's logged into their Albert IO. If you had any other AP classes. So the assignments are already assigned on there. It's albert.io is the URL. Just go to albert.io. Okay, so I'm
Good,
going to
by
do
the way,
number.
sir.
What's that?
You're good to move on, sir.
Okay, thank you. So number 12. So we have a piecewise function. Okay, what's the limit as x approaches 2? So I have to consider the left-hand limit and the right-hand limit. Okay, so here, I'm going to say the limit as x approaches 2 from the left. Then I'm going to find the limit as x approaches 2 from the right. Of f of x. So as you approach 2 from the left, wouldn't you use this one because x is between 0 and 2? So if x is between 0 and 2, you're approaching 2 from the left. So this is just going to be ln of 2. If you approach 2 from the right, that means where x is between 2 and 4, you're going to use this one. So when you plug in 2 here, 2 squared is 4, ln of 2. So the all-important question, are these two things equal?
No.
No. So if the left and right hand are the same, your limit does not exist. That's part of our definition when we first learned limits back in chapter 2. In order for the limit to exist at a point, the left and right hand limits have to be the same. So ln of 2, in this case, does not equal 4 ln of 2. So just like on Mean Girls, the limit does not exist.
Mr. Morrison,
Yes.
to determine if it's like differentiable, do you have to do like the derivative from the left and derivative from the right?
Good. Yeah. So if you want to determine if it's differentiable, well, it couldn't be differentiable because it's not continuous. We just showed that. But if assuming these two things were the same, ln of 2 and 4 ln of 2, then you would have to find the derivative from the left of 2 and the derivative from the right. So it looked like this, 1 over x. And this next is 2 ln of 2 And then you would have to figure out these two things are equal. That would tell you, as long as it's continuous, that tells you where it's differentiable. Where this right here, wherever that is. But again, there's two parts to differentiability. So first part, it has to be continuous. This one is not, so you're done. If it's not continuous, it can't be differentiable. But assuming the first condition was met, assuming it is continuous, then you would have to show the left and right hand limits or the left and right hand derivatives are the same. There can't be a sudden change in slope at a point. It has to be the same slope from the left as it is from the right. Okay, so other questions on this page?
Mr. Morrison,
Yes.
14.
can I
14.
go use the restroom real quick?
What's that?
Is it okay if I go use the restroom real quick?
Yeah, that's fine. All right, so on 14. Okay, so again, this is one I'm expecting you to see on the test because they eliminated most, not most, but probably a little more than half, I would say most of series. But one of the things they kept is Taylor polynomials. So I would definitely be prepared to see something that has to do with a Taylor polynomial on your AP test. So 14, if I want to find the value of sine of 1, I'm going to say that sine x, that equals, it's x minus, you could do it the long way if you wanted, where you find like f of 0, f prime of 0, f double prime of 0, all the way to the fifth derivative of 0. But if you know a shortcut, use the shortcut. So the shortcut, since we already know what sine x equals, I can use what sine x equals. So for this one, it's going to be over 3 factorial, and it's to the third plus x fifth over factorial. This is the fifth degree Taylor polynomial. So sine of 1, that just means I'm going to plug in 1 everywhere I see an x. So it's going to be 1 minus, you know, I think I really would have been if we finished at polar and then they closed school for a bit and we didn't get to series. At least we were able to cover what we needed for series, even if we covered more than you're actually going to be tested on. So that was good that we did get through series. All right, so 1 minus 1 cubed is 1 over 3 factorial is 6, plus 1 to the fifth is 1 over 5 factorial, which is 120. And your answer is E.
Morrison,
Yeah.
do you think you could do like the long way? Because I did the long way and I also knew the shortcut and they weren't matching up for me. I don't know.
Okay, let's do the long way. That's good practice. Because
Right.
if I was to guess, I'd actually think you're probably more likely to have, they're not going to give you one that you know. They'd probably force you to do it the long way, so let's do it the long way.
All right.
Okay, so we know that f of x equals sine x. And then f prime of x, f double prime of x, f triple prime of x. And then the fourth derivative of x. And then the fifth derivative of x. Okay, so this is going to go cosine x, negative sine x, negative cosine x, sine x, and cosine x. And it says we are centered at x equals 0. So f of 0 is going to be 0. F prime of 0 is 1. F double prime of 0 is 0. triple prime of 0 is going to be -1. And the fourth derivative at 0 is 0. And then the fifth derivative at 0 is 1. Okay, so because it's centered at 0, I can write it like this. The fifth order polynomial. So I'm going to say p sub 5 of x. So remember, this gives you an approximation for the actual value of sine 1. So this is something like when your calculator does sine 1, doesn't have it just stored in its memory. It's using a Taylor series to calculate sine of 1. Okay, so it's going to be something over 0 factorial x to the 0 plus something over 1 factorial x to the 1 plus something over 2 factorial x squared plus something over 3 factorial x cubed plus something over 4 factorial. Normally it would be x minus c, but our c here is 0. So I'm just writing it as x instead of x minus c. So x to the 4th plus something over 5 factorial x to the 5th. Okay, now I'm using all of these numbers here. 0, 1, 0, -1, 0, and 1. So anytime the numerator is 0, it's just going to cancel out the term. So this term goes away, this term goes away, and this term goes away. So what I have left is my fifth order polynomial equals, so I have x over 1 factorial, which is just x, minus 1 6 times x cubed, and then plus 1 over 5 factorial. 5 factorial is 120. And then you would just plug in 1 here because we're approximating at x equals 1. So when you plug in 1 here, it's just 1 minus 1 6 plus 1 over 120.
Marcin, how come you
Yeah.
don't plug in 1 for all of those, like the test point things?
Because you're plugging in the center. We're centering it at 0. We're approximating at x equals 1.
Okay.
So the number that you're plugging in when you're creating your polynomial is based off of the center.
Thank you.
Can you do 15?
15, let's do 15. Okay, 15. So one, hopefully everyone can look at 15 and think I need to do integration by parts. That's half the battle, is knowing what to do first. Okay, so on number 15, you have 2 factors, and you can't do u substitution here, because if you try setting u equals something, your du is not going to show up there. So like u equals cosine x, negative sine x doesn't show up anywhere. If you set u equal to x, that's not going to help setting u equal to another variable. So I'm going to do integration by parts here. So using Liade, so u is going to equal, there's no ln, there's no inverse, there's algebra. So I'm going to use x here.
Mr. Morrison, we could do tabular integration too, right?
Yeah, you can do tabular here. X integrates down to 0. I'm sorry, I said that wrong. X differentiates down to 0. And then cosine x integrates repeatedly. So yeah, tabular would work, but I think I'll stick with integration by parts just because that covers more problems than tabular does. Sine x dx. So du is going to equal dx. V sine of x. And then I'm going to use ultraviolet voodoo. So UV minus the integral of V du. So when I do U times V, I get x sine x minus the integral of V du. So this one's not bad. So this becomes x sine x minus the integral of sine x, which is negative cosine x. So that'll make this plus cosine x plus c. So 15 is letter B. So again, often the hardest part is just knowing what to do first. Once you got that down, there's usually not a lot of algebra that they're gonna, especially on a shortened test. I'm sure they're not gonna give you a ton of algebra. So that really when you're focused on, when you're studying, focus on what's the first step in each problem. That should be a priority for you.
What would be the case when you have to set it equal to the original equation?
That would be a good question. That's when it uses the last two letters of Liade. So if it uses a T and an E, so like if you had sine x times e to the x, you have a trig factor and an exponential factor. Then you'd have to set it back to the original. Because
Okay.
T and E, it doesn't matter which one comes first. So you can let U be the T factor or the E factor.
Cool.
I'll put the dx here. Okay, other questions on this page? And we only have like 45 minutes left. Time flies when you're doing calculus. Okay, so I'll go to the next page. So this is 16 through 23.
Do 17.
17. Did you know that 17 is my all-time favorite AP problem? I think this was on your final. I love 17.
Wait, you said was?
Is
Whoa, no, you said was.
it was on the final, but it is my favorite problem.
All right.
Silence is golden. Okay. So right here, 17. You'll never hear me say this again. This is my favorite AP problem ever. So in 17, it's a twice differentiable function. Which of the following is true? Okay, what is f of 1 equal?
Zero.
0. It's just the y coordinate at 1, which would be 0. F prime of 1. So at 1, that's supposed to be a tangent line. Is that positive or negative?
Positive.
That's a positive number, right? Isn't it increasing at x equals 1? So I can say this is a positive number. If you want to find the second derivative, what's the concavity at x equals 1? Is the graph concave up or down?
Down.
It's down. It makes like a sad face. It's increasing at a decreasing rate. So again, this, I know we talked a little bit about this last time, and I just, that's I know the whole goal for with everything going on in the world right now. They're trying to get it. It's going to keep increasing the number of cases, but they're trying to get it so that it's increasing at a decreasing rate. Because right now it's increasing at an increasing rate. So we know this is going to be a negative. So that means out of these three, the smallest one is going to be f double prime of 1, because a negative is going to be smaller than any of the others. And then 0 is f of 1. That's going to be in the middle. And the positive values has to be the biggest number. So that's f prime of 1. So for 17, this would be letter D. So because this concavity is negative, the second derivative is the smallest. The y coordinate 1 is just 0, so that's going to be in the middle. And the derivative has to be positive, so that's going to be the largest number. It just ties so much in such a simple, elegant problem.
Can you explain how to test the convergence for part 1 in number 18?
Part 1 on number 18, yes. Let's look at part 1 on 18. I can probably do that with and leave the work up for the other one. Okay, so part 1 on 18, we're looking right here. Well, if I do nth term test, nth term test, so I would say the limit of n over n plus 2 as n goes to infinity. You could do L'Hopital's rule here. So when you take the derivative of the top and the bottom, you get 1 over 1. So this limit just equals 1. According to nth term test, if the limit as n goes to infinity doesn't equal 0, the series must diverge. So this one right here.
Just a moment.
Whoa.
Okay, I found this on the web.
I turned you down. Okay. So this is going to, this one would diverge. So that's okay for 18?
Yeah, thank you.
Are there any other questions on 18 before I clear everything? Or 17?
Can you explain the second one also, please?
Yeah. So the second one, let me use a different color. So this one here, cosine of n pi, that actually makes it alternate. So cosine of 1 pi is 1. Cosine of 2 pi is, wait, I'm sorry, cosine of 1 pi is -1. Cosine of 2 pi is 1. Cosine of 3 pi is -1. So that just makes it alternate. So if you were to take the limit of what's left would just be 1 over n. Doesn't this equal 0? So if it's alternating and the limit equals 0, I can say it converges by alternating series test. It would converge conditionally. You don't have to know that for this year's test, but it converges by AST. But you do need to know alternating series tests, so make sure. So there, I would say almost half of the stuff we learned on series you do need to know for the AP test, according to what they said about a week ago. So alternating series test was one of the tests you do need to know. So it converges by alternating series test. And then 3 is harmonic, so that one diverges.
Can you do 20 after this?
So I'll do 20 next. Any other questions here before I clear the screen? Okay, so number 20. Let's see, I'm gonna use the space up high. Okay, so I'm just gonna call this something. I'll just set this equal to y as a reference. So I'm gonna say y equals the cube root of x. So it's increasing is 1 over k times the rate at which x is increasing. We want to find the value of k. Okay, so I'm going to take, if it's increasing, it's talking about the rate that it's increasing. So that means I need to take the derivative. So I'm going to say y prime. Well, first let me write it as x to the 1/3. So y prime is going to equal, I bring the 1/3 to the front. I subtract 1 from the exponent, so 1/3 minus 1 becomes -2/3. So the rate at which it is increasing would be, let's see. I'm not doing it with respect to x though. I'm doing it with respect to a different variable. So let me, instead of writing this as y prime, I'm going to specify this is dy over dt. So I'm going to take the derivative of both sides with respect to time. Even though it doesn't say t, I'm just going to create like a dummy variable. So that means if I'm taking it with respect to time, I have to do chain rule here. So I have to times this by dx over dt. So that's going, so now I can say this is one way to express how it's increasing. Another way to express how it's increasing would be 1 over k times the rate at which x is increasing. So when I put that in calculus terms, that'll be 1 over k times how x is increasing would be dx over dt. So I'm going to set these two things equal to each other. So I'm going to say 1/3 x to the -2/3 equals, I can divide, if I divide both sides by dx over dt, this just goes away. So it's going to equal 1 over k. So it tells me that x equals 8. So I can plug that in here. So I have 1/3 times 8 to the -2/3 equals 1 over k. I can write 8 as 2 cubed. I don't think this would be a treasure for most people. Okay, so here the 3's are going to cancel out. So you have 1/3, 2 to the -2. That's the reciprocal of 2 squared, which is 1/4, equals 1 over k. So 1 over 12 equals 1 over k. You could cross multiply here or just tell from looking at it that k equals 12.
Mr. Morrison, can you explain one more time why you set the derivative of x to the 1/3 equal to k, or 1 over k?
Well, these are two different ways to describe a rate of change. So I can take the derivative, or I can use what it tells me is a rate of change. So it's just, yeah, so I mentioned right here, it says that the rate is 1 over k times dx over dt, or how x is increasing. And another way to find the rate would be to take the derivative of the original function, which is cube root of x. So I'm finding two rates of change that describe the same thing. That's why I'm allowed to put those two rates of change equal to each other.
Gotcha.
Okay. Other questions on this page?
22.
22. Let's look at 22. I'm going to clear this out. So which of the following must be true?
Oh, never mind. I read one of them wrong. Never mind. Yeah, we can just move on.
Oh, you're okay with 22?
Yeah.
Everyone else is okay with 22? Okay.
Can you still
Can we
do
do
it?
25 though?
Okay, I can do 22. So, well, looking at the first choice, if you know the limit of this is finite, according to the integral test, if you can get a real number, that tells you that the original series converges. So this first one would be true by the integral test. And basically what's given to you is based off the integral test. So I don't have to keep going if I know that this first one is true. It says, and there's none that say like 1 or 2 or A, B, or C. It just says which of the following must be true. So A is true, that has to be my answer. So that's based on the integral test. If you can get a finite number, any real number, that finite just means it's a real number. It's not infinity, it's not negative infinity, it exists. So that's what the integral test tells us, that the series is going to do the same as its integral. So if the integral is finite, it converges, so the series does also. Actually, probably, did I tell you to do that one?
Yes.
That's an okay one to do because it has other tests that you need, but I don't think you have to know actually, you know what? You do have to know P series though. So yeah, use that reference I gave you from a previous Google Classroom post. It tells you exactly what part of series you need to make sure to know for the AP test. Are you awake, Daniel? Okay. All right, other questions on this page?
25.
25. Let's look at 25. That looks like U substitution to me. Okay, so right here, I'm going to set U equal to negative x cubed. Since when I take its derivative, it shows up in my integrand. So du equals, it's going to be negative 3x squared dx. And to get rid of the negative 3, which I don't need, I'm going to times both sides by negative 1/3. So I can rewrite this integral as the integral of, I'm going to change my limits of integration. So when I plug in 0 for x, negative 0 cubed is still 0. Be careful on this next one. As x goes to infinity, negative x because it's going to keep getting smaller and smaller as x keeps getting larger. So I'm going to write this now as e to the u. Instead of x squared dx, I can substitute that with a negative 1/3 du. So I'll pull out a negative 1/3, and I'll put my du here. So everything now is in terms of u. So from this, I can get to my answer. So this is going to be negative 1/3. The integral of e to the u is just e to the u from 0 to negative infinity. So this is going to be negative 1/3 Well, as u goes to negative infinity, that's the same as like 1 over e to the u. That's just going to go to 0. So as u gets smaller and smaller, e to the negative 10, e to the negative 100, e to the negative 1,000,000, e to the negative 1,000,000,000, that starts getting closer and closer to 0. Minus, when I plug in 0 for u, e to the 0 is just 1. So negative 1/3 times negative 1 is just positive. So it's going to be letter C.
Mr. Morrison,
Yeah.
can you explain how you get the limits of integration in terms of u again?
Yes. So I'm using this equation right here. And then I'm plugging in this number and this number in for x. So when I plug in 0 in for x, it's just going to stay, oops, backtrack, hold on. Let me see, I'm plugging in this and this. So when I plug in 0 in this circled equation, you just get 0, so it stays 0. When I evaluate as x goes to infinity, negative x cubed approaches negative infinity. Like negative 10 cubed, negative 100 cubed, negative 1,000 cubed. It just keeps getting smaller and smaller. So that's why it's going to go to negative infinity. That's okay? All right.
Yeah.
Other questions?
So how come you wouldn't change the limits of integration, like flip it so that zero's on top and negative infinity's on the bottom?
I mean, you could change the limits of integration, but if ever you switch them, you have to make it positive. So, or you change the sign, I should say. So like if you wanted to write it like this, if you wanted to change this negative to a positive 1/3, so anytime you switch them, you always change the sign of, so then it would be e to the u from negative infinity. So that's the only time. Whenever you switch the limits of integration, just always make sure to make your answer its opposite. So I would just always leave them where they are, so you don't have to ever take the opposite.
Cool, thank you.
Uh-huh. Any other questions on this page?
Can you do number 26?
What did I hear before 26? I'll do 26, but I thought I heard one before that.
27.
27. So I'll do 27, then I'll do 6. Okay, so 27.
I'm pretty sure
27.
Skip problem.
What's that?
I think 27 is a skip problem.
Oh, problem. Okay, yeah, it's be careful because yeah, it's according to the update, you have to know Taylor polynomials, but not Taylor series. So 27. I can do that one really quickly. If you were to set the series equal to f of x, I don't think you would get anything like this, but just to be extra safe. So from n equals 0, so a sub n x to the n. So if you want to take the derivative, you would bring the n to the front, and then it'll look like you'll end up getting, let me actually erase the sum part. I don't need that here. Okay, so when you take the derivative of, so I'll let my function equal this, and then I should do f of n. I'll just keep it as f x. The derivative, it becomes n a sub n x to the n minus 1. So when you find f prime of 1, you just plug in 1 for x. So I didn't want to keep it as x. So n times a sub n, which is letter D when you make it a series. So again, I wouldn't stress over that one. But just, yeah, I don't think you'd see anything like that. But you will have to be able to construct Taylor polynomials. So we did, yeah, Taylor polynomials was the first thing we did when we learned about series, and Taylor series was one of the last things. We tied it all back after we did all those tests of divergence. Okay, so 26. Number 26 here. Trying to figure out where I have room. Just use this space for 27. Okay, so on 26, okay, so logistic equation. So remember the rate of change, the graph is telling you how it's changing over time. So for this one, I'm going to say that dp, so the very first way I told you to write it was for logistic differential equation, it's going to equal some constant k. So that means it's directly proportional to the population times the difference between the capacity and the population. So I'll just say A is the carrying capacity. So A equals carrying capacity. So looking at the equation up here, it gives you this right here. And it says you want to find the limit. So the limit represents the horizontal asymptote. That's where the maximum carrying capacity is. So what I'm going to do here to this one is as d, keep doing that, d over dt equals, I want to get rid of this 5,000 so that it looks like this, where p doesn't have anything in its denominator. So to get rid of the 5,000, I'm going to factor out a 1 over 5,000. So this is going to be, when I factor out a 1 over 5, that means you do 2 divided by 1 over 5,000, which is 5,000. That'll give you 10,000 minus p. So now, hopefully you notice these two forms look the same. So this form right here, so we were able to write an equation, differential equation, in the same form that we first learned it in your notes. Okay, so A, let me use a different color now. Isn't A the carrying capacity? So A right here is the same as 10,000, and that is your answer. That's what the limit is going to equal, because the graph is going to look like this. It's going to go up like this, and it's going to approach some carrying capacity, which is the maximum population that an area can support for life. So right here, we would say our carrying capacity is 10,000. So this would be some species. You wouldn't expect the population to ever increase beyond 10,000. Answer would be E.
Can you do 28, please?
Okay, so I'll do 28 next. Before I do 28, I want to make sure, I know we'll do other logistics, but I want to, hopefully as we've done one of these on each test now. Were there any questions on 26 before I do 28? You're okay, Shrey? Shrey, are you okay? Are you just You're okay, Shrey? Thumbs up if you're okay.
Yeah.
Okay, just making sure. You look very comfortable there.
I was just on mute. On my bad.
That's okay. All right, so 28, if there's no questions on 26. Okay, 28. Okay, so this one here. Well, when you plug in 1, this is an x right here, if it's hard to tell. So as you plug in 1, what's the integral from 1 to 1? Someone speak up and tell me the integral from 1 to 1 is 0. When you plug in 1 on the bottom, what's 1 squared minus 1?
1.
What's 1 squared minus 1?
1. 0.
0. Don't we have 0 over 0 here? So we can use L'Hopital. So I can write this as the limit as x approaches 1. When you take the derivative of the numerator, you're using fundamental theorem of calculus. You're taking the derivative of the antiderivative. So that means you take your x, you substitute it for t, so it's e to the x squared. If there's a constant on the bottom, it does not affect your derivative. So the numerator is just e to the x squared times the derivative of x, which is just 1. And then I take the derivative of my numerator, I'm sorry, the derivative of my denominator. That's going to be 2x. That says x squared minus 1. It started with 2x. I evaluate this limit. It's e to the 1 squared, which is just e, over 2 times 1, which is 2. So 28 would be this. And then I also took the derivative of the bottom. So remember, the derivative of the antiderivative gets you back to where you started. We have to plug in for the dummy variable. So anything else on the non-calculator questions? So we're good through 28. Okay, I can go to the calculator. Or actually, let me see. Actually, anything, I forgot we had this the right side. Questions on 76 through 81.
Can you do 79, please?
79, let's do 79. Okay, so 79. For what value of A is F continuous? I don't think you'll see one like 79. Probably if I could go back in time, I might have you skip that one. Just not, that wasn't even like one of the concepts. I feel like this is more like pre-calculus than calculus. And that was after 1998, they eliminated any of the pre-calculus problems.
Well, aren't there holes at like 1 and 4?
Let's see, well at 1, well, if x equals square root of A, it wouldn't be continuous. Because that would cause 0. It only has a hole if you can cancel common factors on top and bottom. So you wouldn't be able, if A was 1, it was 1. Let's see what happens. If A is 1, you have x plus 1, x minus 1. And the x minus 1's cancel out, and you'd have a hole of 1. Yeah, so that would, 1 would cause a hole. Okay, so for this one, at some point, x is going to equal square root of a, so I'm just going to say none. So you can see at 1, it would cause a hole at 1, so you were correct. But it says for what values of a is it continuous? So it's not going to be continuous anywhere because somewhere x can always equal square root of a.
So
is that okay for 79?
in the new
Go ahead.
denominator,
Say that again.
considered or
I don't. For some reason, it's cutting off on me. I would just say you would want. At some point, x is going to equal square root of a. So it doesn't matter what a equals. X can always be square root of a. So it's never going to be continuous for all values of x. So hopefully that answered your question. I don't know, sometimes the audio cuts out on me a bit. I'm not sure why. Okay, other questions?
78.
78. Let's look at 78. Okay, so on 78, here, so this one, this is kind of similar to one we did on Monday. So dr over dt equals, if it's at a constant rate of 0.1, that means it's negative 0.1 describes how the radius is changing. And then the circumference, what is the rate of change? So circumference is 2 pi r. What is the rate of change of the area? So I'm going to say a equals pi r squared. I'm going to take the derivative of both sides with respect to time. So this is 2 pi r times dr over dt. And it says in terms of the circumference. So instead of 2 pi over r, I'm just going to write that as c. And then dA over dt is going to equal the circumference times dr over dt, which is negative 0.1. when you substitute this in here. And that's the answer, which is the same as B. All right, so anything else on this page?
81.
81. Okay, so I'll probably do 81 and wrap it up with that one. Okay, so on 81, so last problem of the day before we meet again on Friday. So I'm going to write dy over dx as 1 minus y squared to the 1/2. It's saying knowing the first derivative, we just have to take the derivative once to find the second derivative. And if I didn't get to any of your questions, we'll pick up where we left off on Friday. So we'll go back to 2000. Don't have to worry about that. Okay, so then I have 1/2 and then 1 minus y squared. When you subtract 1 from the exponent, you get negative 1/2. So I'm gonna, it looks like the answer choices have a radical.
Do the chain rule.
I have to do chain rule.
Yeah.
Chain rule, JK. So I have to do chain rule here. Brain freeze. I don't know, I don't have to rush. Okay, so chain rule, when I take the derivative of the inside function, it's gonna be negative 2y. But I'm taking it with respect to x, so I sprouted dy over dx here. So using chain rule, that's the derivative of my inside function right here. So now this is going to equal. So a positive times a negative is going to make it negative. The 2's are going to cancel out. So you have y dx dy over dx on top. On the bottom, it becomes 1 minus y squared to the positive 1/2. And then this is going to equal. Well, now what I can do here is I know what dy over dx is. It equals this. So I can substitute that in for right here. So I'm going to write that again as 1 minus y. That's the same as saying to the 1/2 over 1 minus y squared to the 1/2 y, and then all of this cancels out, and you're just left with, oh, I need my negative. You're just left from right here. So this is going to equal negative y. So letter B. Okay, so any questions on 81? Okay, so the key here is making sure that you plug back in for dy. You would never leave your answer with the dy over dx in it if you don't have to. So plug back in square root of 1 minus y squared in place of your original derivative, which was given to you as dy over dx. Okay, so the extra credit today is to take a picture of any notes, any math notes that you have today, and just submit that on Google Classroom. So you can do that right away. So make sure to get the full extra credit. You submit your picture of some math notes. It could just be 1 page of math notes, that's fine. And put that on Google Classroom right away, because it is due in the next 10 minutes. Okay, so if you have questions, definitely stick around. If